Hi, in this video, we will explore the fundamentals of hypothesis testing. It's a cornerstone of data analysis. So by the end of this video, I hope that you'll get a basic understanding on hypothesis testing and how to set it up uh, for your any of your analysis project. So let's start. Intro to hypothesis testing. Now, let's see what is hypothesis testing. It's a method used to make decisions or inferences about a population based on the sample data. So, basically, it helps us to determine if our assumptions about the data are actually supported by the evidence or not. So, what is hypothesis testing? It's a, as I said, we want to make some assumption. We made some assumptions about the population, and we want to test those assumptions if those assumptions actually valid for the population or not. So now we have a population. Now let's say um, we have an assumption that all the individuals in the population above an age, let's say, of 60 are diabetic. This is an assumption about the population, right? So to test this assumption, we would need to collect the data of all the individuals in the population who are above 60, age 60, right? So for reaching out to the whole population and collecting the data uh, of the whole population would be impossible, and it would be cost and time consuming, costly affair and effort. So to owing to the limitations of these reaching out to the population, we would draw out a sample from the population sample which is representative meaning it would display the similar characteristics of population. And let's say we have a population of 50 lakhs. From that we will draw out a sample of maybe, let's say, 5,000 individuals who are of representative of population, 5,000 individuals, and we will collect the individual who are above 60, and we will collect the data on their diabetic conditions, and we will go for the analysis on the sample data, so that we can validate our assumption that all the individuals above 60 are diabetic or not. Now, what are the fundamental things of uh, hypothesis? key concepts of hypothesis testing are: one, null hypothesis, which is H naught. It basically it's a assumes that there is typically there is no difference, or in other case, uh, and the alternative hypothesis is denoted as H1, and it challenges the null hypothesis and says there is a difference. Right. Now, another thing is significance level, which is denoted as alpha, and it is a threshold for deciding whether to reject hypothesis. It's a threshold to decide whether to reject H naught, null hypothesis. Commonly, it is accepted level is 0.05 or 5%. So it basically says that there is a 5% risk of there is a 5% risk of concluding that a difference exists when there is no difference. So basically, we are saying that we are accepting the 5% risk of concluding that a difference exists, but actually there is no difference. And another way of saying this, we are 95% confident that our for easy understanding, our assumption is valid. Now, again, another thing is p-value. P-value, it tells us the probability of obtaining our sample results or something more extreme, assuming a null hypothesis H naught is true. So basically, a p-value less than alpha significant level means we have enough evidence to reject our null hypothesis H naught. So it basically tells to reject null hypothesis, but it's not that we found evidence towards like alternative hypothesis. We are basically saying we could not accept the null hypothesis of there is no difference, but uh, we will accept the alternate hypothesis. It does not mean that we have proof towards alternative hypothesis either. The other thing is errors like type 1 and type 2 errors, right? So type 1 error is rejecting H naught when it is actually true. Rejecting null hypothesis H naught when it is actually true, a false positive. Meaning, now earlier in our example here about the diabetic, our assumption would be there is no difference in the um, age group. Like let's say age group of 60, we are assuming that all the uh, individuals above 60 has a diabetic, right? So we are basically saying there is no difference in the diabetic condition of uh, people aged 60, and our alternative hypothesis is there is a difference, right? Now what we are saying by type 1 error is we are rejecting H naught, meaning there is, we are saying uh, there is a no difference, but still we are rejecting H naught, meaning we are saying uh, there is a difference when there is no difference, right? I hope it is clear. Basically the result should have been there is no difference in the diabetic condition of people above 60, but we are saying that there is a difference in the diabetic condition of people above 60. Type 2 error is failing to reject H naught when H1 is true. Failing to reject H naught when H1 is true. A false negative. So, meaning our in the example we have evidence towards H1, mean alternate hypothesis, but there is a difference in the diabetic condition. But we are saying there is no difference in the diabetic condition. So it's called a false negative. Then that is called type 2 error. Another example, let's go with an example um, of a coin. Say testing a coin. So we want to assume that you want to test if you have a coin and um, head, tails, right? And you're assuming if your coin is fair or not. Now your hypothesis, null hypothesis would be your coin is fair. The coin is fair. Like 50% chance of heads and 50% chance of tails, 50 each. So in another words, we are saying there is no difference, right? The alternative hypothesis would be the coin is not fair, or it's biased towards one uh, side, either heads or tails. So the chance of heads is not 50 or 50%, or the chance of tails is not 50%. In other words, we are saying there is a difference, right? Now you flip the coin 100 times and record the flip the coins 100 times 100 times and record the results each time. Right. And if you observe, let's say, observations, head, tail. Now you are your observation was 60 heads and 40 tails. Now you can calculate a test statistics. That further we will I will make another videos on the statistics to determine whether this deviation from 50 heads is this random chance, is this due to, is it happened due to a random chance, or it happened intentionally. So that you will do a test statistic to check whether the this thing is um, happening randomly or inherently there is a bias, so that it is happening intentionally. For this you perform a test called Z score, which we can find in another videos, to determine whether this is a random chance or due to inherent bias. So from the Z-score test, you will get a statistic, test statistic, and you can compare the test statistic to a critical value. Compare with the critical value from the distribution table. Distribution table. Here we are using Z-score, so we will use a Z distribution table. So we will see these when we discuss about the test statistics, and then you can decide whether to reject or not, whether to reject the null hypothesis or not. Whether to reject reject as null hypothesis. So from this, if your calculated p-value from this test is, if is less than 0.05, then we found evidence towards p-value. We have enough evidence to reject null hypothesis. So, and we can say that null hypothesis, if it is less than 0.5, we can reject this. We can reject this and accept this, that coin is biased, coin is not fair. We found evidence towards, or you can write that found evidence towards alternative hypothesis H1. But if your p-value is greater than 0.05, you write fail to reject null hypothesis H0. So this is how the hypothesis testing is done. So in the upcoming videos, so we will I'll plan to go deeper into the how to use different tools like Excel or Python or R, on conducting the hypothesis test. Yes, right. So before this, I will make a short video on, or like a maybe a detailed video on types of hypothesis testings available, and depending on the data type, you can choose your test statistics also. That I will discuss in the other video. So, in this video, we'll learn the core ideas behind the hypothesis testing. Um, core idea behind hypothesis testing, and what hypothesis is, what hypothesis testing is, and how to set it up, and how to make the decisions based on the how to go about the hypothesis testing, and how to make decisions based on the test results. So yeah, now if you found this introduction helpful, please like the video and subscribe for more similar data science tutorials. And if you have any questions or suggestions, please leave in the comments. Thank you.